Hey, Mr. Simon here. Today we're going to introduce the Create Performance task. The performance task asks you to write a program and then submit a video and answer a few questions about the program to the College Board website. If you go to apcsprinciples.github.io, you can find a link for this presentation and links to the College Board materials for the Create task. You can write a program in any language you choose. We've been using JavaScript this year, so you probably want to use JavaScript unless you've been using another language and you're more comfortable with that. Normally there'd be a multiple choice part of the exam as well, but that's been canceled for 2020. So once you write your program, you're going to add two additional things. You're going to have a video of your programming running that demos the program, or at least one feature of the program. And then you're going to have a written description of the program along with the code. All materials need to be submitted to the College Board Digital Portfolio as final by the end of the day, Tuesday, May 26th. Now, in previous years, there's been some problems with the College Board website as we get close to the deadline, so I think you want to submit it at least a day or two before that and avoid the technical issues that come when everybody tries to put it in at the last minute. Your program doesn't have to be complicated. In fact, it's better if it's simple. It does need a few requirements, and we're going to talk about what those are in terms of abstractions and algorithms. But you're not being graded on how sophisticated your program is. You're being graded on how well you explain it and understand it. So you can do anything you want. You can do a simulation, an animation, a data visualization, a game. It's really up to you. All points on this come from your written description. So the video is a requirement, but you're not graded on the quality of your video. Likewise, the program and the program code are a requirement, but you're not graded on your ability to program or the quality of your code. All the points come from your written description, where you answer the questions about your program. If you go on the College Board website, you'll see some samples of videos that show programs running. I won't show you now, but it's worth looking at it. If you want, it's not required. You can narrate over your video the way I'm narrating right now. I use this program Screencast-O-Matic, and I recommend you use it too. It's very easy and free to get it started. If you're having trouble using your computer, you can always use your phone to take a video of your program as well. Again, you're not being graded on the quality of your video. You just need a video that shows your program does run. The College Board provides a booklet that's got the complete instructions. It's called the Assessment Overview and Performance Task Directions. You can get that at apcsprinciples.github.io. And they also provide you with a template where you write your answers. Now, these boxes here get bigger. They expand as you type into them. You're not expected to write a lot, but you will write more than a sentence or so. Most of the answers should be roughly 100 words. There is a maximum number of words, but you're not going to need that to get full credit. For Part 2A, you're going to either in written form or in your narration say what programming language you used, identify the purpose of your program, and then explain what you're seeing in the video. Here's a sample response where somebody wrote a choose-your-own-adventure game in Python. Part 2B is one of the more challenging ones. This is where you're going to need to describe how you developed your program. And they're going to be interested in problems you had while you were working on your program. So it's good to have that in mind. When you start working on your program, expect to have problems because you need problems. You want to write about those problems, and we'll talk about how to do that later. Here's a sample response where the programmer talks about the difficulties he had in coding his program. And then in 2C, you're going to capture and mark the algorithm that you developed for the program. Now, the algorithm, this is one of the main requirements. The algorithm has to incorporate two other algorithms inside of it, and it must have math and or logic. It also has to be created by you independently and not part of another assignment. However, if you want to add a new algorithm to a game like Tron that you wrote as an assignment, you can do that. You want to be clear that this is an additional independent algorithm that you wrote on your own. And then you're going to describe how the algorithm works with the other two sub-algorithms and how it helps achieve the intended purpose in your program. Here is the sample that the student who wrote the adventure game used. And he's writing in Python, but it looks like JavaScript in that this is a function, fightbeast, and the fightbeast function calls two other functions that this programmer wrote. He wrote another program called Schrodinger and another function called buttons. So this fightbeast algorithm has multiple steps. It's a function that has a algorithm with multiple steps inside it, and then within that are calls to two other functions that also have multiple steps inside them. We see a little bit of logic involving true here, but hopefully he's got a little bit more math in the Schrodinger and buttons functions. Yeah, here we go. We can see in Schrodinger we have a lot of logic, and we're doing a little bit of math here to compare hit points and make sure his hit points are greater than 0. So there he achieves the math and logic requirement. And you only need one or the other. You need both, and you don't need them in all your algorithms. There just has to be math or logic in one of them. Finally, you want to do your abstraction. Your abstraction is probably going to be a function that you wrote that manages complexity in your program. The abstraction should also use math and logic. So in this case, he's using, talking about how the code implements an abstraction to handle the function buttons, and that saves complexity because he can just call the buttons function when he needs it. Finally, you're going to take all your program code and you're going to save it as a PDF and mark the algorithm with an oval and the abstraction with a rectangle. Now, we have a tool for this that's going to make this easy, so don't worry about it. I'll show you how to use that when we get here. But you can see he's put ovals around the algorithms that he has in his Schrodinger and fightbeast functions, and then he's got a rectangle for that button, those button functions, new 1 button, new 2 button that he wrote to help manage the complexity of the program. It's okay if you have a algorithm that's inside of a function and you're using that as your abstraction as well. That's perfectly fine to have your algorithm and your abstraction the same function. So as of today, you want to start thinking about finishing up wherever you are on Tron. Remember, it's not necessary to add a computer opponent. That's a fun extension, but that's not required for the assignment. And then think about what you want to do for your create task. You really want to make sure that you keep track of any problems you have so you can talk about them. That's one of the big parts of the assignment. And that you have an algorithm that incorporates at least 2 other algorithms and an abstraction that helps manage complexity. And we're going to talk more about examples of that later, but I do have a video up on abstractions and algorithms that show a couple of examples, but we're going to see more too. So if you got any questions, let me know, and thank you for watching.